Sodium and chlorine are elements. An element is a substance that is entirely made from one type of an atom. Anything that occupies a space and has mass is composed of an atom. Do you know that chemicals are atoms? Honestly, even as humans are made up of atoms, and just like us, they tend to have different relationships with each other, which are called chemical bands. But why do atoms want to band in the first place? If you will try to observe neutral atoms, their associated ions have different physical and chemical properties. Take this as an example. Sodium can form a metal that burns vigorously in air and reacts explosively in water, while chlorine forms a gas that is extremely corrosive and highly poisonous to animals and plants. Yet together they form sodium chloride, a dinner table salt. How is it even possible that the violently reactive sodium and chlorine elements make a harmless table salt for our daily lives? Well, when two atoms approach, they have the potential to chemically combine. If metal and nonmetal successfully combine, then ionic band will result. This process involves the metal donating its valence electrons to a nonmetal element, consequently creating a compound with a stable band. Furthermore, this compound is composed of cations and anions or positive and negative charges, respectively. In regards to sodium chloride, sodium metal loses an electron, and the nonmetal chlorine gains that electron. Here's the process of how ionic band is formed in sodium chloride. Sodium chloride is made up of two elements, sodium and chlorine. The atomic number of sodium is 11, which means that electron configuration will be 2, 8, and 1. In order to become stable, sodium needs to have a full outer shell of 8 valence electrons. However, its outer shell has only 1 valence electron when it is by itself. When talking about valence electrons, we could use a Bohr model to point where the valence electrons are. It will look like this. So the easiest way to achieve full outer shell is to lose just 1 valence electron. Chlorine with an atomic number of 17 has an electronic configuration of 2, 8, and 7, and needs just 1 more valence electron to become stable. So if sodium gives up its 1 valence electrons to chlorine, both elements will have full outer shell, thus they will become a stable compound. This means that by transferring 1 electron from sodium to chlorine, both become stable and unreactive as an ionic compound. Additionally, the compound has a hard yet brittle structure. If asked why did they discover ionic bonding, simply my answer will be food would be blunt without it.